600 meters down, near the Antarctic convergence, a submersible light cuts a narrow tunnel through absolute black. Something drifts into the frame. It is not swimming, it is drifting. Longer than a great white shark, heavier than a grand piano. Eyes the size of dinner plates catching the beam like two wet moons. And somehow, size is the least interesting thing about it. For over 100 years, we knew this animal existed only from beaks in sperm whale stomachs and torn corpses tangled in nets. In 2025, a submersible finally filmed one alive. And what that camera saw was not a monster, it was something stranger. The animal is the colossal squid. Not the giant squid you have seen in 100 documentaries, a different animal, bigger, colder, living in a completely different part of the world. And in almost every way we thought we understood, wrong. Picture something that big, moving that slowly, in water that black. 10 meters long, roughly the length of a stretched limousine. Half a ton of soft body, hooked arms, glassy skin, and one enormous nervous system suspended in near-freezing water. You would expect a predator like that to be everywhere in the story of the deep sea. Splashed across textbooks, filmed 1,000 times, studied on every research vessel that has ever pointed a submersible south. You would expect it to be a household name, the way great white sharks are, the way blue whales are, the way orcas are. It should be one of the icons of ocean biology. Instead, for a century, it was a ghost. Think about that for a second. We landed rovers on Mars. We tagged blue whales across entire oceans. We mapped the seafloor in enough detail to find single lost airliners at the bottom of the sea. And in that same century, the largest invertebrate on Earth stayed almost completely off camera. Not because it is small, not because it lives in one tiny place. It lives across the entire Southern Ocean, circling Antarctica in a ring of water bigger than most continents on Earth. And still, until recently, no one had ever watched one breathe. That is the first contradiction. The second one is worse. Everything you have ever heard about this animal, almost every fact, every measurement, every drawing in a museum, was reverse engineered from a corpse. Sometimes not even a whole corpse, sometimes just an arm, sometimes just a beak, dug out of the stomach of a sperm whale. The species was first named in 1925 from two arm crowns found inside one of those stomachs. Two loose pieces. That was the whole animal, for science, for decades. A rumor confirmed by leftovers. Now think about what that means. We described the largest invertebrate on Earth, mostly from what ate it. Every documentary before this one was a guess dressed up as a fact. Every illustration was a reconstruction from parts. The animal in your head right now, if you already knew this species existed, is almost certainly wrong. Because the shape it makes when it is alive and the shape it collapses into when it hits a boat deck are not the same shape at all. They are barely even the same animal. For most of the 20th century, science had to work with those leftover parts. A hook here, a tentacle there. An intact adult carcass would occasionally come up in a fishing net, usually damaged, usually already partly digested, usually already dying by the time the net cleared the surface. Museums preserved what they could, artists drew what they imagined, and the animal grew in human imagination while shrinking in scientific certainty. The more people talked about it, the less anyone actually knew. And that is where the 2025 footage broke everything. A team working with a research submersible in the Southern Ocean caught something on camera that no one had ever recorded before. A living juvenile colossal squid drifting in the beam, transparent, slow, unbothered. Small enough to hold in two hands, glass-like, delicate, arms hanging loose in the current instead of striking the camera. No aggression, no lunge, no monster. Watch that clip and try to feel scared. You cannot. And that is the problem. Because for 100 years, this animal has been sold to the public as a horror. A kraken, a leviathan, the nightmare that eats the nightmare, since sperm whales themselves hunt it. And then the first honest footage arrived, and it looked like a suspended piece of glass with tentacles. Scientists watching that tape went quiet, and they did not go quiet because it was scary. They went quiet because the animal we invented in our heads was not the one that showed up. So the real question is not what the colossal squid looks like. The real question is what it actually is. And to understand that, you have to go inside its body, because almost nothing about that body works the way you would expect. Start with the flesh. You would assume a predator that big is packed with muscle. Dense meat engineered for speed, the way a tuna is engineered for speed. Wrong. The colossal squid is closer to a floating balloon than a torpedo. Its tissue is saturated with ammonium chloride, a chemical lighter than seawater. Its own body chemistry is the reason it does not sink. Here is why that matters. At 1,000 meters down, water pressure is crushing. A dense body would need to burn enormous energy just to stay off the seafloor. So the ocean, over evolutionary time, found a loophole. Instead of building muscles strong enough to fight gravity down there, it built flesh that basically ignores gravity. The animal is neutrally buoyant. It hangs in the water like a jellyfish, but with the outline of a predator. That is why every corpse hauled onto a boat collapses. The animal was never built to hold itself together in the air. On a trawler deck, under sunlight, it looks like a melted sculpture. In its own water, at its own pressure, it looks like a ship. The meat also tastes, by all reports, like floor cleaner. Ammonia does not translate well to a dinner plate. Anyone who has ever tried to cook one has quickly learned why the colossal squid has no commercial value. The chemistry that keeps it alive down there is the same chemistry that makes it inedible up here. It floats. Which means this animal is not a hunter in the way a shark is a hunter. It is not chasing anything. It cannot chase anything. It is a drifter, a patient shape moving on ocean currents and slow pulses of its fins, waiting for the world to come to it. It is closer to a jellyfish in its lifestyle than to a great white, even though it looks nothing like a jellyfish and could tear a great white to pieces if the two ever met. Which brings us to the part of its body that has haunted marine biologists for decades, the eye. The colossal squid has the largest eye of any known animal in Earth's history, larger than any dinosaur, larger than any whale, roughly the size of a soccer ball. Some estimates suggest as much as 27 centimeters across. Imagine that. Something the size of your head, wet, black, unblinking, mounted on the front of a body that already looks impossible. Two of them, one on each side, together weighing more than an adult human's entire brain. Now here is where the story stops being impressive and starts getting strange. You would assume a giant eye evolved for seeing in the dark. That is the obvious answer. And it is not quite right, because at the depth this animal lives, there is almost nothing to see. The sun does not reach. Ambient light is essentially zero. A bigger eye barely helps you notice anything, because there is barely any light to gather in the first place. Above a certain size, an eye stops giving you significantly better vision in darkness. It becomes expensive tissue that does not pay for itself. So why is that eye there? The leading theory, worked out by researchers studying vertebrate and invertebrate vision, suggests something almost cinematic. The eye is not built to look at prey. It is built to detect the faint bioluminescent disturbance kicked up by something enormous moving through the deep. Tiny plankton and shrimp glow when they are disturbed. A large predator swimming through them lights up a cloud of sparks in its wake, a slow-moving cloud of biological light that trails behind it in the black. From very far away, in absolute darkness, an eye large enough could just barely register that glow. And what predator is big enough, hunting deep enough, to leave a trail like that in the Southern Ocean? The sperm whale. 40 tons of warm-blooded, echolocating muscle diving 2,000 meters into the cold for one specific reason: to find and eat animals like this. That eye is not built to see prey, it is built to see the animal hunting it. Read that sentence twice. The largest eye ever evolved on this planet exists because something in the dark is coming for it. It is not a predator's eye, it is a survivor's eye. Every wet centimeter of that soccer ball-sized organ is a piece of biology assembled by generations of ancestors that either saw the whale coming or did not. and only one group of them left descendants. Which means, for all the fear this animal has carried in human imagination, it is not sitting at the top of the food chain. It is looking up, and it is watching for something warm. Now, the colossal squid does not go quietly. Look at its arms and you will see a feature that separates it from every other giant cephalopod on Earth. The giant squid, its more famous cousin, has suckers, rings of muscle that grip. Effective in warm water, reliable. The colossal squid replaced most of that grip with something worse. Hooks. Rotating swivel hooks that sit inside the suckers on its two long tentacles, sharp and curved, mounted on tiny bases that let them pivot in any direction as the prey struggles. It does not grab, it gaffs. The reason is temperature. In freezing Antarctic water, suction is unreliable. Rubbery tissue does not seal well when it is stiff with cold, so evolution swapped suction for puncture. When a fish drifts too close, the tentacles fire, the hooks bury into flesh, and the swivels turn to prevent tearing loose. Now picture those hooks on an animal that cannot chase you. It does not have to. The prey came to it. That is the trade the ocean made. Slow body, cheap grip, sharp weapons that only need to work once. The hooks are patient. And this is where the biology stops being scary and starts being strange in a completely different way. Behind those hooks, past the arms and the beak, is a brain. And that brain has an architecture no engineer would ever design. It is shaped like a donut, a ring, because inside the ring passes the esophagus, the tube that carries food from mouth to stomach. Every meal the colossal squid eats passes directly through the middle of its own brain. That is not a joke. That is real anatomy shared across cephalopods, and it forces a specific rule on how they eat. Prey has to be shredded into small pieces before it goes down, because if a piece is too large, it damages the nervous system while being swallowed. That is why the beak is so brutally sharp. It is not decorative. It is not for defense. It is a food processor bolted to the front of a brain that will punish greed with self-injury. Eat too big and you concuss yourself from the inside. Think about that as a design constraint. This animal is one of the largest predators in the deep ocean, and the physical architecture of its head requires it to eat delicately, slowly, in careful bites. A monster with table manners forced on it by its own anatomy. That is not what you expected when you clicked on this video, and it is not what marine biology expected either. When researchers first understood the donut brain layout, there was a period when nobody quite believed it. It felt too absurd. But the animal has been living with that layout for hundreds of millions of years, longer than most vertebrate lineages have existed. Whatever the compromise is, it works. But there is a reason the ocean tolerated a design like this, and the reason is temperature. The colossal squid lives in some of the coldest water on Earth, around 2 degrees Celsius near the ocean floor of the Southern Ocean. At that temperature, muscle chemistry runs slow, nerves fire slow. Everything metabolic in that body is throttled. Some estimates suggest the colossal squid has one of the lowest metabolic rates of any large predator ever measured, roughly a third of what a warm-blooded animal your size runs on, maybe less. Some researchers suspect the animal barely burns any energy at all when it is drifting, that its baseline metabolism is closer to a resting deep-sea fish than to a mammal or a shark. The colossal squid is not lazy. It is running on a metabolism roughly 1/3 the speed of yours. Imagine trying to hunt if your heart could only beat that slowly. You could not chase a fish. You could not fight a rival. You could barely think fast enough to react. So the ocean redesigned the entire concept of predator around a body that cannot afford to burn energy. Ambush, drift, wait. Let the buoyancy do the work. Let the hooks do the killing. Let the prey come to you because you cannot go to the prey. It cannot chase, it waits. And that slow metabolism comes with a hidden cost, which the surface world barely notices. Growth is slow, reproduction is rare. If something disturbs the population, it recovers slowly, if at all. Which means the colossal squid is not just hard to see, it is fragile in a way that its terrifying appearance completely hides. The most intimidating invertebrate on Earth is also one of the slowest to replace itself. And in a warming ocean, in a southern ocean that is changing faster than almost any body of water on the planet, a slow reproducer is exactly the kind of animal we should be paying attention to. And now the sperm whale comes back. Because if the squid is that slow, something has to eat it, and that something has to be fast enough and warm enough to descend into water that would kill almost any other mammal. A sperm whale dives with a rush of clicks so loud they can stun small fish. It descends to depths near 2,000 meters. In the cold and the dark, its clicks bounce off the soft body of the colossal squid and paint a picture in the whale's brain. The chase is not really a chase. It is more like a slow, deliberate kill by an animal built for pressure and holding its breath. The squid's only defense is that giant eye. Early detection. See the whale coming from far away. Try to slip sideways in the current. Sometimes it works. Often it does not. Every hook scar on a sperm whale is a fight we never saw. The white circular marks on the skin of old male sperm whales are stamped there by rotating hooks and suckers that gripped the whale as the squid was pulled apart. Some scars are the size of dinner plates. Some are bigger. They are the only record left of a violent underwater battle in a place no human eye can go. When a fisherman or a whaler sees those scars, he is looking at a war fought 2,000 meters below the surface, in water no camera has recorded, between two animals engineered for opposite strategies. Warm blood versus cold flesh, sound versus vision, speed versus stillness. And usually, the warm blood wins. The kraken has a nightmare too, and here is the part that made scientists realize how blind they were. For a century, we knew the sperm whale was eating colossal squid. We knew this because sailors and whalers cut open sperm whales and found the beaks. Thousands of them sometimes, packed into a single stomach. From those beak counts, from the ratio of squid to other prey, marine biologists estimated a global population of colossal squid. A guess, a number, a best attempt. The population of the largest invertebrate on Earth is estimated by counting what its predator eats. That is not census data. That is triangulation from teeth marks. The entire scientific idea of how many colossal squid exist in the Southern Ocean rests on a chain of assumptions. How many sperm whales dive that deep? How often each one eats? How large a portion of their diet is squid? How many meals each whale takes per year? Multiply, adjust, hope. We do not know how many are down there. We know how many disappear. That is not science. That is triangulation from teeth marks. And the harder question is why we cannot do better. Why, in the age of satellites and autonomous submersibles, we cannot just go count them. And the answer takes us back to the animal's body, to the ammonia, to the gelatinous flesh, to everything that made this animal succeed in the deep. Bring a colossal squid to the surface and you destroy the animal you are trying to study. The eyes deflate under lower pressure. The tissue collapses under its own weight. The chromatophores, the color cells in the skin, fade. The delicate hooks tear as the arms drop. The whole shape sags into a puddle of ammonium-saturated meat, and by the time it hits a research bench, you are not looking at the animal. You are looking at what is left of it. Every colossal squid you have ever seen in a museum is a shape it never made alive. Think about that. For 100 years, every reconstruction, every model, every drawing, Every specimen jar in a scientific institution was showing the audience a body that could not exist in its own habitat. The real animal never made it to the surface. The real animal only exists at pressure, in the cold, drifting in black water where it belongs. Which is why so much of what we thought we knew was subtly wrong. We were not failing to find it, we were failing to see it in a form that still looked like itself. And this is why the 2025 footage matters more than any specimen ever collected. Because for the first time, a camera went to the animal instead of the animal being dragged to us. For the first time, a colossal squid appeared on screen in the shape it makes when it is alive. Not the wet ruin on a boat deck. Not the puddle of collapsed tissue in a preservation tank. The actual living outline of the animal, moving on its own terms in its own water. And that shape was not what anyone expected. The juvenile filmed by that submersible was small, transparent, and calm. Its arms drifted. Its body pulsed gently. It did not attack the camera. It did not flee. It hung in the beam like a piece of blown glass with a nervous system inside it. For a moment, the entire narrative of the colossal squid, monster, kraken, nightmare of the deep, collided with a piece of biology that looked almost tender. That is why the scientists got quiet. Not because it was scary, because it wasn't. The most feared invertebrate on Earth, seen alive for the first time in a century, looked like a child. Because it was one. A juvenile drifting through the middle water column, still small, still fragile, still years away from becoming the 10-meter shape we build myths about. And the myth cracked. Not because the adult is not real, it is. But because the animal we invented in our heads never had a childhood. It was always a monster. And the ocean does not build monsters. It builds survivors that grow into whatever shape survival takes. We built a monster in our heads for 100 years. And then we met it. So return, one more time, to the shadow at the beginning of this story. The drifting shape in the beam. Longer than a great white, heavier than a grand piano. Eyes catching the light like two wet moons. And ask what it was actually doing there. Because it was not hunting you. It was not hiding from you. It was drifting on a metabolism you cannot match, through water you cannot survive, watching a sky lit not by the sun, but by the disturbed sparks of tiny lives it will never touch, waiting for the shadow of a warm predator to move somewhere above it. The colossal squid did not stay hidden for 100 years. We were just built wrong to see it. The next one is drifting somewhere right now, slow, cold, waiting for a shadow that is not us. And somewhere in the black water off the edge of Antarctica, a submersible light will fade, and the animal will keep going. Not because it is escaping, not because it is retreating, because it was always going somewhere we cannot follow. And the ocean, quiet again, keeps the rest of the answer.